Okay, in this problem, we have a company that introduces a new computer game in a city using television advertisements. So surveys show that P% of the target audience actually buy the game after X ads are broadcast. So P is the percent of people, that's what this tells you, that buy the game after they see X ads. Okay, so we're going to work through this problem in here. So what percentage buy the game without seeing the ad at all? So that is when X is 0. Ignore that. When X is 0. So let's go over here and plug in. So you're just plugging in 0 for X. So P of 0 would be 100 over 1 plus, this is going to be 48 times e to the negative 0.16 times 0 is 0. So e to the 0 is 1, so it's really 100 divided by 1 plus 48, or 49. So I'm opening the calculator up. We're going to compute that number. Is 2.0408 nearest 10. So 2.0. Okay. And we've got to plug in 44. What percentage of people buy the game after seeing 44 ads? That's a lot of ads. Okay, so we'll just have to enter that into the calculator. So 0.16 times 44. Let's do times negative 1. So that's the exponent. So I want to do 100 divided by 1 plus 48 times e to the power of what I just got. Second answer is about 95.96. Oops. Rounding, that would round up to 96.0. Huge percentage. Oops. There we go. There we go. Okay, find the rate of change, or the derivative of P. Okay. So two ways: you could use quotient rule, or you could rewrite P of X. I'm going to rewrite it as a with the denominator to the negative 1. So 100 times 1 plus 48 e to the negative 0.16x, all to the negative 1. So I'm just rewriting the function, and now I'm going to differentiate that. Okay, so now my derivative would be, I need to use the chain rule. So bring the negative 1 down, just get negative 100, because the 100 just carries along, times 1 plus 48 times e to the inside function. Okay, so all of that is to the minus 2, times the derivative of this entire inside function. The derivative of 1 is 0, and the derivative of this part is going to be 48 times the derivative of e to the negative 0.16x. Well, the derivative of that is another chain rule, right? And it's e to itself times the derivative of this inside function, which is negative 0.16. Okay, so then let's clean this up a little. I've got this negative and this negative are going to multiply to become positive. I've got 100 times this 48 times this negative 0.16. Let's see what that simplifies to. So 100 times 48 times 48, it's negative 0.16 is, I don't know why I put the negative in there, but the number is 768. Okay, Okay, so all of those combine to 768. That's the 100, the 48, and the 0.16. And then I'm going to put this e out front, e to the negative 0.16x times all that to the minus 2. Or you could write it in the denominator squared. Okay, so then we need to enter that in here. So 768 e to the negative 0.16x times 1 plus 48 times e to the negative 0.16x to the negative 2. Okay. So that's the rate of change of p of x, and then sketch a graph of the function p. It's kind of interesting. So we know that, actually we can pick it from the parts A and B, because we know that when x is 0, p is 2, and when x is 44, it's 96. So it's got to be this one. That's the only logical choice that goes through. Anything close to 2 and 96. I wouldn't ask you necessarily to graph that. I'm not really sure what purpose that serves in this problem.